day, learners! Welcome to another session of fun learning. Today, we are going to have the laws on radicals. With this lesson, you are expected to simplify radical expressions using the laws on radicals. Note that the laws of radicals are derived directly from the laws of exponents. So let us proceed with the laws on radicals. In simplifying radicals, a radical nth root of A is said to be in its simplest form if it satisfies the following conditions. First, the index of the radical is greater than any exponents in the radicand. Second, the radicand is free of fraction or decimal. And the third, there are no radical in the denominator. Take note that the nth root of 0 is equal to 0. We let m and n be positive integers and x and y are positive where m or n is even. Then we have the first law on radicals. The nth root of x, quantity raised to n, is equal to x. Meaning, if the index and the exponent are equal, we can simply cancel it out. So, we are left with the radicand, which is the simplified form of the radical expression. So, for example, we have the fifth root of 6 quantity raised to 5. So, we can, since the exponent is equal to the index, simply cancel it out. So, therefore, we have 6. Next, we have the fifth root of negative 1 quantity raised to 5. It is equal to negative 1. Again, the index and the exponent are equal, so we are going to cancel it out. So that makes it equal to negative 1. Next is we have square root of 64. Since 64 is a perfect square, so we can rewrite square root of 64 as the square root of 8 squared. That makes the index and the exponent equal to 1. So therefore, we have 8. For example, if your radicand is negative and your index is even number, we have no real root. Why? Because it is not defined in the real number system. However, if we are going to have this expression, we have the square root of negative 2 squared. We can cancel it out. However, we are going to take the absolute value of the radicand. So it is equal to the absolute value of the radicand. That makes it equal to 2. So take note, this expression and this expression are not the same. Because if we are going to simplify negative 2 squared, that would be equal to positive 4. The second law of radical is the nth root of xy is equal to the nth root of x times the nth root of y. In this case, we can factor out the radicand in order to simplify the radical expression. So for example, we have the square root of 32. Since our index is 2, we must think of a factor of 32 which is a perfect square. And in this case, the perfect square factor of 32 is 16. So we are going to rewrite square root of 32 as the square root of 16 times 2. Therefore, we have the square root of 16 times 2. We simplify square root of 16, so that is equal to 4. And we are just going to copy square root of 2. Thus, the square root of 32 is equal to 4 times the square root of 2. Next is we have the cube root of 40. Since our index is 3, we need to identify the factor of 40 which is a perfect cube. And in this case, cube root of 40 would be equal to the cube root of 8 times 5. Since the perfect cube factor of 40 is 8. So therefore, we have the cube root of 8 times the cube root of 5. So we simplify cube root of 8, so that is equal to 2, and copy cube root of 5. So next is we have the fifth root of negative 64. Take note that the radicand is negative. However, our index is an odd number. So therefore, we have a real root. So we need to identify the factor of negative 64 which is a perfect fifth. So what number is a perfect fifth factor of negative 64? Yes, we have negative 32. So we are going to write the fifth root of negative 64 as the fifth root of negative 32 times 2. So therefore, we have the fifth root of negative 32 times the fifth root of 2. So we are going to have fifth root of negative 32, so that is negative 2. Copy fifth root of 2. Next, we have the fourth root of 32, x raised to 11. So first, let us write fourth root of 32, x raised to 11 as the fourth root of 2 raised to 5, x raised to 11. In other words, we change 32 as 2 raised to 5 since 32 is a perfect fifth. Since the exponents of our radicand is greater than the index, factor out the fourth root of 2 raised to 5 x raised to 11 in such a way that one of the factors is a perfect fourth root while the other one is non-perfect nth power or non-perfect fourth root. So how are we going to do that? First, we need to find the greatest common multiple of the index. So for the numerical coefficient 2 raised to 5, the greatest common multiple of 4 that we can derive from 5 is 4. So we are going to factor 2 raised to 5 as 2 raised to 4 times 2 raised to 1. While for x raised to 11, the highest multiple of 4 that we could derive from x raised to 11 would be 8. So therefore, we can factor x raised to 11 as x raised to 8 times x raised to 3. So therefore, we can have this radical expression. We have the fourth root of 2 raised to 4 x raised to 8 times 2 raised to 1 x raised to 3. Take note that if the exponent is 1, we need not to write it on our expression. So we are going to separate the radicand. So we have the fourth root of 2 raised to 4 x raised to 8 times the fourth root of 2x cubed. So therefore, we have 2x squared times the fourth root of 2x raised to 3. Third law on radical is the nth root of x over y. So this will be equal to the nth root of x over the nth root of y, where y is not equal to 0. So for example, we have the fourth root of 8 over 81. We separate the numerator and denominator as the fourth root of 8 over the fourth root of 81. So the numerator cannot be simplified since 8 is not a perfect fourth power. So we just copy it. While the denominator, since 81 is a perfect fourth, we can rewrite 81 as 3 raised to 4. Therefore, the exponent of the radicand and the index are the same, so we cancel it. So therefore, we have fourth root of 8 over 3. Next, we have the fifth root of negative 5 over 32. So we are going to separate the numerator and denominator in order to simplify the given radical expression. So we have fifth root of 5 over the fifth root of negative 32. Take note that the negative is placed in the denominator so that our radical is free from a negative radicand. Why? Since the denominator is a perfect fifth, therefore we can rewrite fifth root of negative 32 as the fifth root of negative 2 raised to 5. So we can cancel the exponents and the index. So therefore, we have the fifth root of 5 over negative 2. Third, we have the fourth root of 3 over 16 r raised to 8. So we are going to separate again the numerator and denominator as the fourth root of 3 over the fourth root of 16 r raised to 8. So fourth root of 3 is already simplified, so we are just going to copy it. While for the denominator, 16 is a perfect fourth, while r raised to 8, our exponent is a multiple of the index, which is 4. So we can rewrite fourth root of 3 over the fourth root of 2 raised to 4 r raised to 8. Therefore, we have the fourth root of 3 over 2 r squared. Next is we have seventh root of negative 5 over h raised to 21. So we write it as the seventh root of negative 5 over the seventh root of negative h raised to 21. Since our numerator is already simplified, we are just going to copy it, while for the denominator, 21, which is the exponent of negative h, is a multiple of 7. So therefore, we can divide 21 by 7. So therefore, we have the seventh root of 5 over negative h cubed. Next is we have the mth root of the nth root of a, which is equal to nth root of a is equal to the nth root of the nth root of a. Meaning we can interchange the indices of our radical expression. For example, we have the sixth root of 4. Our index, which is 6, could be factored as 3 times 2 or 2 times 3. So therefore, we could rewrite 6 root of 4 as the cube root of the square root of 4. Since 4 is a perfect square, we can rewrite 4 as 2 square. So therefore, we have the cube root of the square root of 2 square. We can cancel out the exponent and our inner index. So therefore, we have the cube root of 2. Next is the square root of the cube root of 4. In this expression, square root of the cube root of 4, we can interchange the index of our radical expression. So we could have the cube root of the square root of 4. Square root of 4 is 2, therefore we have cube root of 2. Next is the cube root of the square root of 27. 27 is not a perfect square. However, it is a perfect cube. Therefore, we can interchange the indices. So we could have square root of the cube root of 27. Cube root of 27 is 3. Or we can rewrite square root of the cube root of 3 cubed. So therefore, we have square root of 3. Next is the 10th root of 32b raised to 5. So 10 is already a big index. And we can factor 10 as 2 times 5. So therefore, we can rewrite our radical expression as the square root of the 5th root of 32b raised to 5. 32 is a perfect fifth. Therefore, we can have the square root of the 5th root of 2 raised to 5 b raised to 5. So as you can see, the exponent of our radical is equal to our index. So therefore, we can cancel it. Therefore, we are left with the square root of 2b. Now it's your turn to try the activity. Pause this video while you answer. So are you done answering the activity? If yes, let us check your answers. Did you get the answers correctly? If yes, well done. If not, you may click the replay button of this video to better understand the lesson. So thank